All right, I'm not gonna worry too much about it. For some reason, my alerts are always broken. Might have to look at that at some point. All right, so let's get started. So I left off sort of in the middle of things. I was working on. What was I working on? Working on the TIA. I was sort of working on it inline, I believe. And I was doing implementing sort of like one thing at a time. I actually don't think it's so much of an issue, but I'm gonna put something here. That's what I was just reading about. Just so I know to handle this. Our sync um, can be ignored in most cases. It's one game depends. It's handled correctly. I'll come back and deal with that later. Call this a to do. And then this is covering the same ground. So basically, let's get oriented here. What is happening is I am implementing enough of this stuff on the TIA to set and get to draw something to the screen. And then I'm hoping to get to actually opening a window and drawing something. I think my music's a bit loud. Cool, I'll turn it down. I think it was like low five before, so. It's funny when you're in all lowercase dead beef, it looks like ox dead beef, which is. Uh, I don't know what to say about that, but cool. Let me look at the microphone volume, make sure that's looking good. Testing, yeah, it should be good. Okay. um, cool. So, yeah, and then the thing is that the all sort of Atari programs go through all addresses from 0 to 256, setting everything to 0. So I can't just implement set for some things. I have to like implement it for everything. Um, so I was hoping to be able to just like leave it to blow up when we encounter something new, but in fact, everything gets set at the beginning, including wsync. We have to do something special with wsync, but we'll do it later. I just want to get all this stuff up here. Um, my program, let's actually just go ahead and open that up, that I'm running from, which is the one I built several years ago. I think in intro.tasm, I think it only uses the play field to write out tic-tac-toe, which is good because that means that we don't have to worry about the actual sprites and some of the missiles and all that other stuff yet. We can just render out the background in the playfield first. So those are the things we'll need from here. So we're going to skip over just like most of that, and then we'll implement uh, a lot of this stuff actually. Actually, maybe not that much. Eventually, we'll get to input. Probably actually nothing from the read. Yeah. Okay, cool. There's some playfield stuff there. So, where were we up to? remembering my key bindings here for buffer, so I'm back over here. Up through 7 inclusive, so you need to deal with 8. Actually, yeah, these are player colors, so we're going to do the next two, which is color background, color play field. Colors are 7-bit colors, which is super cool and weird. I'll have to go look that up because it actually works different depending on where the TV is. Um, and I don't really understand the sort of electronics behind all of that, but I think it has to do with the refresh rates from the American TVs versus European TVs. It's PAL versus NTSC, and so like all the sounds are different. All like colors are different. It's just a weird thing. And the clock speed is actually different between those two. So we're doing. So we're going to be doing that. Okay, so, and background. So we actually need up through 6 inclusive. Zero X 7. We're gonna do self dot. What is it called? Color value. It says it doesn't know what that is, so I'm just gonna say colors, and we'll do U8. We're gonna need one for the background, so we'll just go ahead and add that. Is it BK or BG? Let's see. I think it's BK. And I had oh, so it is actually 8 and 9. Boy, take me a second to get back into all this. So this is 8. This is 9. And let's be K. So control playfield. I actually do think we need to store that. The controls whether it's reflected or not. So let's take a look at. Okay, a reflected playfield may be requested by writing a 1 into bit 0 of the playfield control register. This bit is true. Okay, so we'll actually just handle the part we need here. And that is for control playfield. So it's just this one reflected playfield in bit 0. So it's at OA. So we'll do control. this is a Boolean flag. So basically we're gonna grab did you work with a different platform emulation before, like NES or Simulator? I'm wondering how it compares to the 2600. You've done your fair bit of NES. No, I haven't really done too much. I've done of course, the Chip 8 sort of like intro to emulators. But I think that so in some ways it's going to be really similar because the NES has a version of the 20 or the 6502 updated version. So NES processor. I don't remember it off the top of my head. You may know better than I do. Oh, that's not what it. Oh, okay, so it's got this extra process. It's got a core that is the 6502. Yeah, okay. So like the assembly programming is going to be very similar. If I remember correctly, the big difference is like sort of like the programming model. So basically and you'll have to tell me, there's no like with the Atari, there's no like sort of screen buffer. The only sort of state that it holds around is like where different sprites are and like where the playfield is, and you basically have to like kind of update it in time for the beam to get drawn. So you don't have like enough space to have any kind of like screen buffer or anything like that, or even like, if I remember correctly, you could do like tiling with the NES where you've got like where you can like point to a tile and like have a grid of those. So it's not a full screen buffer, but it's like something similar, and then you can mess with it. I know there's like a fair amount of like low level stuff you have to do, but yeah. Uh, so the programming model is significantly different. The programming model in the Atari 2600 is really about sort of timing the beam. So in an emulator, I can see people going a couple ways about it. But I feel like if you have a system that's sort of high enough level, you can like not have to worry about the details of how old TVs worked, and just emulate like some of that stuff. And this, like, I kind of have to get into like how long a scan line took and like where like the color clocks on the TV driver and stuff like that. So that is I think that's the difference in the emulators, but I haven't looked into NES emulators very much. I know I watched somebody build a large portion of a Nintendo 64 emulator, and like there's definitely some difficulty there, but like the abstraction level was way higher, right? Like he didn't have to worry about like what scan line the beam for the TV is on and stuff like that. So, um, yeah, I would be interested in doing that. Oh yeah, Ferris. Yeah, of course. Yeah. Um, I wouldn't have tried emulating anything unless I watched Ferris build emulators and realized that it's like very approachable. Um, so let's see, reflected. So we're gonna take a value, not double and it out. And then one is reflected, I believe. Actually, we can look at. One second. Don't reflect playfield. So if it's 0, it's not reflected. If it's 1, it's reflected. Okay. Gazillion mappers. What would a mapper be? Yeah, I think the instruction set is almost the same. I think the Atari has a 6507, which is like a reduced functionality 6502, and so I think that like they're pretty much the same. There might be some things that you have access to on the Nintendo that you don't have on the Atari. So if this equals 1, then it's reflected. The other stuff on other parts of control PF. We don't care about OB through OC. Then we care about the next 3 registers. Yeah, we'll have to be careful about that top one. Are you working, Dead Beef, are you working on the emulator like these days, or are you doing other stuff? Sorry, let me PFO through PF2. So that's oh, I see. Yeah, yeah, yeah. Yeah, there's a little bit of that on the Atari. Yeah, okay. Yeah, there's a little bit of of that on the Atari, but like not a ton. There's like a few supported extensions. Basically, you can some cartridges have extra RAM, which is nice because there's almost none on the base system, and some of the cartridges uh have bank switching, which is like they can have more. I don't know exactly how it works. I'll have to implement it at some point, but uh you can have like more program memory basically, and like there's some you have to deal with whatever bits are set to control which one you're on and stuff like that. um, but I'm hand waving it because I don't know it very well, and I will have to learn it eventually, but not now. So but nothing like the Nintendo. I know that they like were putting graphics cards and stuff on them, like, or on the Nintendo. That was a Super Nintendo, but I know that the Nintendo was extended a lot. Uh, so we're going for PF0 through PF2. Unhappy baby again. She seems to know when I'm streaming. Let's see if I have to. So for PF0 in particular, we only get 4 bytes of it, and it's the upper 4 bytes. So I think we need to do self.pf0, and then we can. I think we can like and equals this one with. How do I do hex? That's the question. With this, I think that's get us the upper 4, and then the other ones will be easier. And we don't need that. Wait, no. We need that doesn't work. We need the value. The value here. And then one more. Okay, we don't need to deal with. So this is a playfield register. We don't need to deal with anything. Oh yeah, I know that too. They're like with like the multi-game. Yeah, because like a lot of the games were actually a lot of the games were actually the early games were only 2 kilobytes of program memory, and the I don't the ROMs would like mirror them twice, so you could like address either address like there's a bunch of weird sort of like address mirroring stuff that goes on with the Atari, um, since there's so much of the like potential address space that isn't used. Um, so I don't need anything. Clear horizontal motion registers, clear collision. So I don't actually need the rest of it, I think. I think I've got everything I need. So I have the color for the playfield, a color for the background. I have um, the playfield registers, the control playfield that I need, and then the rest is like audio, some graphic stuff, controlling the motion of the player, all that stuff. So I should be able to go up through 2C. And then everything else will be... I'll handle it specifically because I do need to handle everything through 2C like explicitly, but if I do 1.0... 2C, right? And then everything beyond this shouldn't even be possible. 0 2C. Oh boy, fingers. So this is going to be similar to 4. Ignored for now, and then the rest is actually not unimplemented, it's just unreachable. What is it not like about that? I think it's fine. If I cargo run this, it should be able to run through the whole memory. What does it say? 2D. Okay. I'm not doing something right. I'm setting this. Okay, let's see. There might be some unused ones that I'm not handling properly because it does mirror, but it also like so that should be handled. So yeah, okay, so it mirrors at starting at 4.0. So I need to actually just use the unused ones, which is 0x 2D, including 0x 3F. These are unused, but shouldn't be an error trying to set them. I'm printing something out, but let's not print that out. I think that might be in my main program. Print line. I'm printing all the instructions. So that's what's going on there. So I think I'm going to get myself into a infinite loop here. Yeah, that's exactly what I expected. Because I don't have any input, I'm just sitting on the title screen without switching over. So I'll need to start implementing some of that stuff that I was talking about to be able to see anything. So let me think, what is next? I don't need to implement any of the gets. I think I need to implement wsync, but let's do a commit first. I think there's some comments I should clean up in here. To do needs a real implementation. Trying to read a player input, blah, blah, blah. I have a real implementation. I think this actually maybe needs to move down to our read function. I think I moved it. Yeah, that's what this is right here. This is so that the input doesn't appear to be pressed. Because this is sort of, there's a term for it for people who know electrical engineering, but it's active low or something like that. I think that's what it's called. All right. Let's add that to the last commit. So this is a set for a field. Push it. Second time. Cool. All right. So the next thing that we need to do before we can actually get to graphics is we need to implement what happens with wsync. And so let's take a look at exactly what happens with wsync. There might be a couple TIA things we need to implement too. So basically, wsync is will set a flag on the processor that we're not going to deal with directly, that prevents it from continuing to take new instructions until let's see. I can address wsync setting this latch high. When this latch is high, it drives connected to the micro ready line. That's right. So to halt and wait, and I should have figured too, the latch is automatically reset to 0 when the leading edge of the next horizontal blank timing signal releasing the ready line, allowing the microprocessor to begin its computation and register writing for the horizontal television line or line pair. Line pair is that thing where some programs don't switch graphics or colors every line because they might not have enough processor power to, so they do it every 2 lines. So you get like half the vertical resolution, but you is that right? I think you get half the frame rate, so you get 30 frames per second, and then those are interlaced, so every other one is drawn. So we'll have to deal with that eventually. Hopefully not immediately. Okay, so we'll go to main. So we a little bit are going to fudge this W sync. So instead of having it turn off a thing on the processor, we already have the ability to like tick the whole system forward, and it updates its clocks, and then it updates the write, which is synchronized. It's a different chip that's synchronized. So we're also going to have we're gonna have this. This may not be the next thing to do, though. Let me back off because I don't think that's the next thing to do. I think the next thing to do is to have the riot or the TIA just tick ahead. So where was that? W sync. W sync is at O2. It's setting a flag to W sync equals true. And basically after we are doing the TIA set, we're going to change the yeah, okay, so we're going to change the signature of memory set to return a this it needs to be more than a U8. Have it return a U size. So you don't have to worry about it. And then you see everywhere we have these issues or these things, we need to actually switch this. In general, we're going to return a U size 0. But in the case of the TIA, we're going to return. We're going to say we're going to return something different, and this is going to be the number of ticks that we want the TIA to advance the clock. And we have to do this sort of. We're going to have to bubble this all the way up. Actually, I don't think this is the place to do it. Okay. Let me go back on that real quick. And then when we execute, we're already sending back the number of ticks. So basically we need to say if TIA. So this is the number of ticks for the command itself, but if the TIA wsync is true, actually we don't need to say equals true. We can say if the TIA wsync. Then we need to let me see. I think we've finished taking the command. Then we tick the number of ticks self TIA. So we'll call a method called wsync ticks. So there's a bunch of stuff that's not quite correct here. Okay. Yeah, that's fine. Okay, so it's a wsync ticks TIA. And then calling this method I'm going to just reset this to false. So basically we're saying advance the clock without running instructions by this amount. So that'll advance all the timers. That'll advance all the, we'll make it advance the TIA when we get there. So I think this will work for us. It's a private member. That's probably why it's saying that. It didn't hate that. So simple TIA. So do function wsync ticks, and we don't know what this will do right now, but it's going to take itself, and it'll return usize. From now, we're going to have it return 0. See what diagnostics we have wrong. Nothing is wrong. Let's see. Cargo run should not fail. It's not. Cool. So I think the things we need for a wsync tick is we need to know sort of where we are at all times in the TIA. So, or in the, on the screen. So that's this. Hold on 1 second. Sorry about that. So I don't think. So I think that we will need fidelity on this. So basically, there's 3 color clock counts to 1 machine cycle. And there's 262 scan lines, which is pretty straightforward. And so each line, so when that vsync is called, if you're like somewhere here in the machine cycles, you'll pick up back at the beginning. And so what I want to do, I think, hold on 1 second. Okay. What I want to do is keep track of where I am in a line at any given time. I could probably do that by keeping track of where I am on the whole picture. So 220, let me zoom in here. 228 and 262. 28 times 262. That is almost 60,000 clocks. But if we say we took that, so we have, say we're at 34,299. and we did the division by. So if we do a mod 228, so we're 99 color clocks in. So if we're at 0. So if we're at 228, we're at the end of the line, or the beginning of the line, because it starts at 0. So if we're at 227, then we would wait one more clock cycle. We shouldn't ever be there though, because we're advancing by processor ticks. So I believe. Yeah, so I believe we can just, on the TIA, just sort of keep track of the frame and then do that as we go. And I don't think we need to worry too much because eventually the system will wait. So I think we can just zero initialize that. Done. Maybe. So we're just going to call this color counts per frame. Or we'll say this frame. Color counts. That'll be we'll just make it a size for now. Field is never read. Fine, this is defaulted up, so it should be fine. So we should be able to do something here. We should be able to self.dia tick with the clocks. There's no tick on the TIA, so we'll implement it. This will take, let's take a mute self and a clocks usize variable or parameter or whatever that is. And then it won't return anything. And then what it's going to do is that for each clock, we're going to have to do some checks. So let's see. The basic logic is self.color clocks. Color, we'll call it clocks. Color clocks plus equals I'm trying to think if something goes over the line. I don't think it really cares too much right now. We'll figure it out. So I think we may be able to just sort of wrap it around at that number, which is like what 59,736. So we'll just make ourselves a constant. Color clocks per frame. Do a couple of constants here, so we'll do color per line. That's 228. scan line. $262. And color clocks per frame is color clocks per line, scan lines. So this should be clocks times 3, because there's 3 per cycle, right? So, and then I think we can't do a color clocks plus equals because we'll need to, so self dot color clocks plus, and this is going to be mod our total number, so clocks per frame, and that should wrap it back around. Everything should be a U size here. Cannot mod a U size by an I32. I didn't declare this, so. So this is, it's saying that I'm doing this wrong, but I think actually what I'm, okay. Didn't have my precedence correct, so there we are. So that it's adding the color clocks and then it's wrapping over if it's not. So the thing is that when we want to know how many syncs left for the W sync, or how many ticks left for the W sync, we're going to convert the other way. And we're going to go self dot color clocks, and we're going to mod that by our clocks per line. Right, so if we're halfway through the line and we mod it by the clocks per line, so we get a value that we can subtract from and then we're going to divide this by 3. I probably need to put some, yeah, definitely need to put some parentheses here. And I think that should give me something reasonable. So what that means is if, say we're at 93 color clocks in, and we want to see how far there is to the rest of the line. So we can say 228 minus 93 is equal to, what's that? 11, 5. Did I do that right? 8 plus 9. It's 13, 5. What? 135. And that's how long we'll wait. Divided by 3. So if it's like an odd, it should always be at a multiple of 3, but if it's in an odd place, will that break anything in particular? I am not sure here. Don't think it can happen. But we do need to keep track of them because you can do stuff like sort of in between the frame, and we'll need to know like which one we're on. We'll see. Maybe we don't need to keep track of them. But this should take everything over wsync. And I think that's kind of it for this. Unless I did something really wrong, but I think I got this. So, we haven't implemented display for TIA yet, so I don't think we're going to mess with that. But what we should see is when we run the thing that I'm expecting to see here that will tell me that what I did worked is as it's counting, like as it's counting up, on the third count up from 0, and it might, you'll see, it should pause for some amount of time. So let's see if that does happen. It did not. It's going too fast to see that. Okay, let's get out of here. So just for fun, let's ePrint line might be fast enough that we can't even see it. So I just want to make sure. That's not where I don't want to go. Debug, because it takes over the terminal. I want to see. It's always 66. That doesn't seem right. And it's happening a lot. Like potentially in a loop. Actually, that might be correct. Although this appears to have broken my... I'm gonna have to kill that process. Cool. Not sure how that happened, but that's fun. Terminated by a kill. So for some reason, doing that got me into a loop where setting TI. So let's see how often this is being set to true. So I just want to see. This shouldn't be true very often. So it stopped there. So what happened? Maybe I just had a weird thing going on. Gotta wait for rest analyzer. Okay, so it stops now. I don't know what happened. So I think that maybe let's see if I can get it to. Okay, so we're seeing a lot of 66 really, really fast. Okay, so we're gonna do something really hacky here. I'm gonna say if not self dot tia dot wsync ticks 66, then print it out. Otherwise, I don't care about it for now. I just want to make sure that it's not just 66 because we shouldn't. That could be when it's in our loop, where we're like on the screen, and that's sort of a deterministic amount of time that we should be waiting, which would be 66 clock cycles every time. That seems like completely. It's only 76 wide. Do I only have 10 cycles wide? We'll see. So it's always 66, including that very first time through. Okay, then I'm going to do something a little different so I can see what's going on here. I'm going to derive debug for this. Struct TIA. And I'm just going to put it out when main. I'm going to debug print it in this version so I can see what's going on. So I should see it down here. Do you think is false? You can see it sort of, so it shouldn't get past. You can see the play fields being set and unset. So what it should do is get up to like, it's a little slow, but somewhere in the 56,000 and wrap back over. Yeah, so it did. So that's color clocks. It's just a different part of the. I'll have to figure out what's going on with this because it should still be setting playfields and stuff like that. Okay, so let me think about this. I think I can probably. Let's see what wsync ticks is. So here I am printing out the TIA. Let me print couple new lines here. That's good. One more. Don't need debug. Should be able to look at our W tick, so that's private, but we can make it public real quick. Okay. So, what'd I do wrong? I somehow printed that again. So you can see it's changing over time. Seems like maybe it's just working properly. Okay, we'll go with that. So we can get rid of that. We'll still print out the TIA just to be able to look at it. And then I'm going to commit that and go. Let's see. Make sure my logic here is good. Okay. This is definitely worth a test at some point. Color clocks plus clocks times 3 clocks per frame. So that seems to be working properly. The color clocks per line seems to be working properly too. And actually, if we slow down the debug break, I think it's up here somewhere. Might be able to see that better. I just want to make sure that I got it right before I go through. So you can see the color clocks are going up, but let's see. So if we look at this, does it appear to be counting down by 3? It might still be going too fast. But it does look like it. Hold on. Give it a whole second between. "66, 63, 59, 57, 54, 56. The clocks left wouldn't. It's the color clocks that would be going. That would depend on the tick. So that's. I know this is riveting entertainment. So everybody's around 12, 24. These all look like multiples of 3. Okay, I think we're good. I think we're going to leave it at that. We're going to set this back there. We'll leave the color clock stuff there for now. Commit this, and then we will get started on graphics, which is what I was here for. Let's see, we've got. Okay. We'll see how far we get. We're implementing TIA, and I think that worked just fine. So the next thing we're going to need to do is copy from a demo project for STL2. I don't remember how all that stuff sets up. I have chosen STL2 because it gives me very close control over the timing of the whole thing, whereas the more rusty version, Winit, does not. And I am definitely looking to switch over once I understand enough about these things. But STL2 is tried and true, and pretty easily allows me to do this stuff. So I did a little bit of work getting a demo project set up, sort of to understand what exactly I was doing. So that's an SDL test. And we'll look at the cargo tomo first, because I think we're going to need just a bunch of that stuff. How am I doing this? SDL test. Cargo tomo. Okay. And we'll look at our own cargo tomo. And we can sort of explain things as they go. So we'll just pull this whole thing over and just talk about it. All right, so we have a dependency on SDL with some specific. We don't need all of these, I don't think. We will need the mixer. That's the audio mixer for SDL2. We don't need that. We need graphics. We don't need true type font or image yet, so we can actually just get rid of those. I may be wrong about image, because I'm gonna be streaming a pixel buffer to SDL2. I think I can do it without image, and so then GLRS is the OpenGL bindings for SDL for Rust, and SDL2 interops with those pretty well. So that's sort of what's going on here. Yeah, yes, I thought about using pixels directly, but there's actually a bug that is not on pixels, but is on the parent library with SDL2 on Macintosh, which is where I was like demoing all this stuff. So it just doesn't work, and something is messed up, and it doesn't, like, one of the views that you need to run on Macintosh like isn't there, and nobody's going to fix it. So for now, we're just going to do it this way. This worked pretty well, and Pixels is doing much the same thing that I'll be doing here with SDL2, um, which is really just keeping a track of a small pixel buffer, and updating it. Yeah, no, that's my work computer, so I was like messing around in my spare time, but I do think I would like to avoid the headache later. Um, so this I do know works. So I think we're gonna go with it for now. But I'm definitely like in the market eventually to update to like pixels plus like WNet or something like that. WNet, like, in order, and I understand like why they made this decision in order to work with, and maybe you actually, Dead Beef, have some insight into this. Having it in order to work on like all platforms, including WASM, where you like can't ever block. They take control of the event loop, and when I checked out the event loop, um, it was actually pretty slow. Not slow, but it was like it took a big chunk of time, um, and I didn't immediately know how to get that back. And like with this in particular, like I like kind of need pretty good control over the timing. Um, so definitely in the market to change this up, but I know this will work for now. Um, I'm having the hardest time. And main. Okay, so we'll do this in our main for right now. I think we can kind of take. I don't know how much of this box size and buff size we need. Feels like it has a fixed frame. Yeah, yeah, I don't. And there was no way to like to break out of their event loop that I could tell. So, um, I'm sure like smarter people than me are using that crate to do better things than I'm going to. So I'm sure there's a way. Um, but in the meantime, okay. So I don't think I need the window event key code. So this is cool. So the buffer we actually need is really small. And the other thing about doing this is that I like can give it a texture and just have it automatically stretch the texture, which I think Pixels also does. But so I only need a pixel buffer of 160 by 192. So I'm not sure what this box size was. What's she doing?
She crawled under the pee pad.
Let's see. I'll take the world. Okay, so this is like a box inside the world, so I definitely don't need the box size. Um, but I do need the buffer size. Oop. We don't need that to be like right next to SDL2. Put it a little closer to main for now. All this needs to get moved out eventually, but we can do that. So let's see. There's some things we need to set up. So we'll pull in this function. This basically just finds the OpenGL driver on our system. And let's see. Video subsystem. So then this is all of our setup. do this. SDL stuff, and I'll sort of explain kind of everything that I'm doing here as well as I can understand it. So we'll do through to the pop. Okay. So this is pretty self-evident. We do SDL2 init. The video subsystem is just sort of what creates allows you to create a window. We'll just say this is Stanley. It's nice. It's family. Atarii 2600. Emulator. Oh my goodness. Can't spell today. For some reason, my fingers are just done. All right, so this is all saying like, what are you doing? Returning a result. Yeah, so we'll need to return a result from main. You can also just unwrap everything, but might as well. What doesn't I like about this? Okay. Window event, blah, blah, blah. Expected result. Okay, so I think one thing is I can return at the end. Am I returning anywhere? Oh, we already have a result. That's why. Okay. I think it's the exact same thing, so. There it is. It's a result of unit, which is fine. Okay. So then we should be good. So then we initiate a window. So the window's actually got to be 4.3. So we'll just do classic 4.3. I think it'll be tiny. 600. Replace this with emulator. We're going to center it. We're going to make it borderless, and we're not going to make it resizable. Eventually, will do that. The reason I'm doing that is because in i3, if I make it resizable, i3 will stick it in a context. So in this case, I just want it kind of in the. I have a typo in Stanley. What did I do? There it is. Brain. The spell checker was telling me, and I don't. I don't know what was going on there. Okay, so then I take that window, turn it into a canvas, find the OpenGL driver. I don't fully understand how all of this works, so a lot of this is taken from examples. But my understanding is that I take that canvas and I say, here's the index of the OpenGL binder, OpenGL driver. Use that to build your canvas, and then I create a texture and a surface from that, a surface that matches that that buffer that I'm going to have with the pixel format. I saw something that that looked like I might get a little better performance if I use one of the supported OpenGL pixel formats. That's a to do. It's definitely a to do. Should I? Because they are slightly different. They're definitely not RGBA. What was that? 32 bits. OpenGL. How's it going, Nomad Pixel? How are you? Yeah, you're actually at a really exciting point here, or at least I hope it's exciting. I am I am about to add graphics to this thing for the first time. So my first step is copying a bunch of stuff that seems to work in SDL2, and then seeing that the window opens, and then I will be hooking up the graphics to it, at least in a very simple way. Choose color or format. I don't think we're gonna have too much of a yeah. I looked into. I was just telling Dead Beef there that I looked into Winit. Even this library called Pixel or Pixels that like gives you a buffer that you like that it streams to a window or something like that. Winit seems to want to really control the timing of things, and so and like the timing is really sensitive for the Atari 2600, especially the way I'm doing it, which may change. I would love to figure out how to do it, but SDL2 just kind of works. Um, I know it's not the rustiest thing in the world, but I figure I can dive into that a little later. So then I have my texture event pump. So the funny thing is this is all a little complex, but I don't need to do any of this if I'm in debug mode. So it's going to be a pretty. Wonder if the compiler will be able to tell that I'm hoping it will. So then if it's not in debug, this is all a big mess, but we'll get there. I want to basically do this stuff. So it's saying no. Yeah, so I don't have the event pump in this scope because it doesn't. There's certainly a better way to do this. I might just ignore the debug case for now. Um, yeah, using pixels. Yeah. Uh, Mini FB. Yeah, I saw that. Yeah, Nomad Pixel. I saw Mini FB in the lineup. I think once I had limited success with Win It, I just sort of went to this side. So I'm just gonna ignore. Hold I'm gonna ignore the debug mode for now because that's just gonna need a rethink. So I'm just gonna unconditionally do this. I think that whole thing is gonna need a rethink. Um, then I have a buffer. Nothing's on that buffer yet. This does some weird breaking out to the. Oh, I see, because it's breaking. Uh, do I actually want it to do that? What is it doing there? Okay, so basically, I'm taking this event puck. I'm going through events. If the event is quit, I want to break out of the outer loop. That's why. That's why it has this like game loop, Atari loop. I'll just leave it like that for now. Um, yeah, dead beef. It's actually pretty simple to. Let me show you on this example here. Um, to just like so you update the texture with your with whatever your buffer is. If you're updating the buffer every time, and then you copy it to the canvas and then present it. It's like that simple. That's a little sort of what Pixels is doing, but Pixels abstracts all that and tries to do sort of optimized stuff about it. So it can be as simple as taking a buffer and just like updating a texture with it. Um, but uh, but if you I don't remember how to do a need the tick to me is a got some overloaded stuff here with the debug. Got two events coming in. We're gonna call this as CT event. Yeah, this all needs some help here. But let's see if we can get it going. Where is that? CT event might be the only thing. Yeah, it's saying there's a bunch of stuff that doesn't need to be mutable, but it will need to be mutable. Nothing is. Yeah, nothing is done yet. Actually, we can go ahead and let's put that. Yeah, actually, let's do what I said I would do and see if that pops us up a window. For just a second. Okay, what happened there? Okay. I'm surprised I didn't see anything there. Seems like there is a window, but it's like quickly disappearing. Maybe I do need to do that canvas.present. It's gonna be like kind of insane. That loop is happening so often. Actually, let's make that loop happen less often. Um, we can mess with that by, jeez, it's a lot of stuff. CL stuff. So we want the clocks to run. Let's make them run for like 100 clocks instead of 10. Let's see if I need to. Actually present something for it to work. So let's copy that over after all this. We'll actually do it if the clocks reach over 100. Hey, we have a blank screen. And all of those bytes are 0. So let's see if we can make it. See if we can make it white for fun. So where's our buffer? Well, that's pretty cool. That's not anything from our Atari 2600 emulator, but that is definitely a it was definitely a window with stuff that we were drawing on it. And it should probably be timed right, but we'll see if that happens. STL stuff. Yeah, I'm just gonna have to rethink how to do that debugging stuff. So then escape works. Quitting the window would work. Cool. I'm gonna commit that. I'm gonna take a very quick break, and I'll be right back to see if we can get a quick thing implemented on the TIA to draw to the thing. Be right back. All right. So even 100 clocks is super fast, right? That's still, let's see, 10 clocks is like 8 microseconds. 100 clocks is 80 microseconds. So this is like far too often to be updating a buffer. So we're going to sort of update our timer here, which is a sort of class we made, utility class for timing this stuff. And we're going to we're going to check basically if timer dot, I'm wondering if we'll just say, we don't have this method yet, but elapsed is greater than duration from I have to remember my math. Do I have this on again? Yeah, I got it on. Okay, cool. So 1/60 times 1,000. Boy. It's just not doing the. Okay. So, better way to do this. I can set the precision on that. So it's about 16 milliseconds. So, I think the better thing to do is if timer frame should render, just go ahead and do that. The cool thing is I think that our timer, as we've implemented it, will be resilient to now the question is, we're going to need a TIA method. So the thing is if it renders right in the middle of the TIA, like drawing the screen, then we're going to like draw half the screen, and it'll look messed up. So we also need to check that the system, and we'll have to implement all this, .tia dot, let's call it should render. Actually, let's not have it know anything about rendering. Let's call it like is uh yeah, right now it does. I have that sort of open question. I think that like the OpenGL native supported, so SDL2, when you have OpenGL support, will do the, like basically will take this and update the texture on the GPU. And there's a question in my head because I think I read somewhere that there is a different pixel format for, or there are other supported formats for OpenGL that are not what is this, 32-bit RGBA. And so like my question is, should I be writing this buffer in this format, in one of those formats, to prevent the overhead cost of converting of them all? Although it's probably not much. Like I said, this isn't like a large number of pixels, um, but we'll see. Uh, yeah, it is a lot. I still think it's going to be better to. I don't remember how many colors it has. I think it's like 16. Um, and it depends on the system. So I would have to see if OpenGL supports anything smaller. I definitely don't need an alpha, so that's definitely a to do for me. Um, so we'll just say like if it's not drawing, and then we should be able to render. And so basically this will run every so often, and if it's been whatever it is, 16 milliseconds, then we'll say, it should render, and we'll keep that going until it does render. Then we'll want to say like timer, do this after present timer did render. Right, this is all like writing the API I want here. And then if the TIA is drawing, it'll just wait until it's done. The worst thing we do is miss a frame, which should be okay. So let's take a look at timer. We'll should render. I think we're gonna need a separate timer. Yeah, we'll need a separate instant. So we'll do render timer, a new instant, right? Because this other one like can go a lot faster, and it just keeps getting replaced. So we'll do timer. We'll do render instant. And then we'll do, what do we need? We need should render and did render. So we'll do pub function should render. This needs a regular old reference to self. This will be a bool returning function, and that'll be self dot render instant collapsed. And if that's greater than duration from millis 16. Render instant. What doesn't it like about that? Did I not instant? Okay, and then I think for now we should be able to do did render. Takes a mute self, returns unit, and then we should be able to say, just replace this with instant now. So then we have the timer stuff implemented, and then we just need the TIA, system TIA is drawing. So we'll go to mod struct TIA. We'll implement pub function is drawing. This is the bool. So we can be a little bit, we could be like super clever with this and like worry about before and after, but we're going to count the vertical blank as drawing. So if it's in these first 37, let me make sure I have that. It's 40 plus 30. 40 plus 30 is 70. Yeah. So if it's in these first 40 lines or it's in this last 30, then we should be good. So if self dot color clocks, so we're gonna do divided by colors per line, and if that's less than 40, right? So that's not quite what we want, because we want the and to and self dot color clocks divided by color clocks per line is greater than 192 plus 40, which is 132, unless I'm going insane. And that should be everything we need for is drawing. All right. Let's see. Let's make sure I didn't break anything terrible. It's saying I don't need the buffer to be mute. In fact, I'm gonna do something a little. I'm gonna have the TIA hold on to its own buffer. So basically, I will do. I just need a reference to TIA.buffer. That is system.tia.buffer, which doesn't exist yet, but will. Then we can get rid of this buffer. Head on over to mod, where our TIA is. We'll give it a buffer. And and that'll be super. And in fact, that should those constants should probably live here. Now maybe super. Buff size, right? And that's a buffer of U8. Doesn't know how to deal with default for a U8 slice, which is annoying. I don't think I can. May have to implement default for slice in Rust. They probably thought of it. Trait implementation is default, right? Is it because it's okay, so I'll just have to implement default. It's fine. It's not too tough. Derive default. How can I implement default? It looks something like that. What? Did I not copy it over? Oh, yeah, right. This terminal requires me to. So I'm wondering if I can just do buffer 0 super buff size. And then default. I'm hoping. That probably doesn't work. Okay, so not all traits are missing default implementation. Need a semicolon there, not the period. Need to actually return the thing, so that's probably mostly why it was complaining. Hey, Perk J, how's it going? Comma. Missing fields. It's for the one. What am I doing wrong here? Okay, now it's just missing a bunch of stuff. Oh, I need to double dot that. Don't need a comma there. Perfect. So that should. It's a private field. That needs to be a public field for sure. Rest analyzer, just being slow. Okay, what is it saying? Cannot recurse without. Okay. Okay. So I just need to implement all this stuff. Okay, that's kind of annoying. Anybody knows a good way around that? I would love to hear it. The buffer where it goes. Everything that its bool is going to be false. Everything that's U8 is going to be 0. And that's, I think it's the only thing that's U size here is 0. Should just implement new, but we'll go with it. Our black screen's there. So if we change our default implementation to white, okay, so we're still there. So then, let me see. I'm trying to get this done, something on screen pretty soon. Hold on one second. Okay. So in tick, basically we're going to start drawing. So okay, so I think the thing that we're gonna do is we're gonna go from our current color clocks. Oh, does it? I did have to run. I did have to run release. Although right now it's not having a problem. I don't think. Well, I mean, we'll see when motion comes up, but it seems like it's not a big deal. We could do some debugging output to see. I did, yeah. When I was like drawing to it, I think I had to run. I think I had to run in release, but I think that's mostly bounds checking stuff. Because I'm going to be running over a bunch of like an array of or big array, and it's like bounds checking every time I'm updating a color. So I think that's what's going on. I haven't dealt with what the colors are. I'm just gonna say if the playfield is here, actually, can I see what happens in debug mode? Okay, I'm gonna open that and bookmark it and see what's going on with lock. Yeah, I tried that too. It didn't seem to make much difference on in my case, but that is definitely that's definitely the way to do it eventually. Right, that basically uses the SDL, the OpenGL streaming buffer, which like has some performance benefit. I don't know exactly how it works under the hood, but yeah, when I tried it out, it just made it a little more complex, but and didn't really change performance at all. But I'm like not, I wasn't doing very much. I was drawing a box in the middle of the screen, so we'll see what happens here. But I'm definitely going to keep that in mind. Let's see. I was gonna cargo run debug to see what my background color was and what my foreground color was, and I might just do black and white at this point. Whoa. All right, I'm printing out that whole buffer. Okay. Maybe I won't worry about it too much. I think I'm just gonna do the background color black, foreground color white for now. I think that'll work. And that we'll deal with that eventually because the colors are here, but I don't know what they map to. So we'll have to figure that out. So if this wraps over, we're going to have to do this a number of times. But for now, I think we're just going to assume that it doesn't, which is not a fair assumption. But I don't think we're moving that many clocks ahead for any reason other than the TIA itself. And we shouldn't in the future. But we'll just do. There's to-dos all over this project. Handle. Clocks being greater than clocks per frame. So basically we're going to say, okay, heads up. I'm going to see if I can get this done real quick, and then I'm going to have to go. We're going to do 4. Trying to decide if we're going to just assume we're even on the same line. I think so. So I think we're going to go 4 I and self dot so I think for each, so we're going to go from wherever we are, and then we're just going to decide. Let's pull this out into a. Sorry, thinking out loud here. So, new. Yeah, this is all wrong. So, but so do we need to be inclusive of the new color clocks? So that's the question. I think so. So we need to figure out where this I is on the line. And then we don't do anything unless it's in a certain spot. But I think that's pretty straightforward. So for if so just get us, yeah, so let um let's say like column equal, um, this is total number of color clocks. And we're going to mod that by the color clocks per line, right? So that tells us where we are on the line. Tells us our column. So if our column is greater than so 68, so 0 through 67. So if it's greater than or equal to 68, then we're going to draw, and it's this 160. Now we have the play field we're drawing is 8 plus 8, so 16 plus 4 is 20. So it's 100, it's actually half of that. So it's 4 color clocks wide for each item in the play field. Okay. So basically, if this is greater than or equal to 68, and then it starts with the first part of the play field, which is the top 4 bytes. So it starts with the top 4 bytes, and if it's reflected, then it switches around and goes the other way, or top 4 bits. We may just need to mess with this and see what happens. So if column is greater than 68, so I need to figure out which one I'm in. So that looks like this. So it's one, I'll just do a little one. So say all of them are set. So then that's 1, 1, 1, 1, 1 for the second one, and then 1, 1, 1, 1, 1. And I think we're reflected in this first one. So then it's actually the same thing, but backwards. 1, 1, 1, 0, 0, 0. Then I just need to figure out how to get the index out of here. So I don't really want to convert these to like a array of bulls, but that might be the easiest way to do it. Hmm. I think, let's see, I got about 15 minutes left. So basically what I want to do is if I'm in, let me make sure that I know how this 0. PF0 is only 4 bits from constructs the first 4 bits of the playing field, starting at the left edge of the TV screen. PF1. Yeah, okay, so I need to like basically like need an array of all these bits. How am I going to do that? So I really want to index into like index equals column minus 68. I can do this kind of rough if index is less than it's going to be gnarly. There's definitely a better way to do this. Probably shifting a bit around and then I'm guessing that's kind of how it works on the chip, right? Is these like registers are right next to each other, and because it's little endian, the high bit is stored last, and so it just kind of like shifts something around, and then like ends it. So how many bytes I have? I have 16 that I need, and then 8. I think that's probably going to be the best way to do this. So I have whatever my index is minus 26. So like basically I need, and if it's reflected, construct playfield index or playfield. And we'll do that from P. It's probably pretty inefficient, but let's see what happens. So self.p0 as U32. So 32, is that enough? Because it's 16, 16, 32. Then we're going to go backwards for over the thing. So I think U32 is fine. And I need to shift it. So basically, as I'm going up, so I have 0, 0, 0. This is gonna be index 1, 2, 3, 4. Yeah, that's not actually. It's not little endian. I don't know. That's not what I'm thinking. So I need to be able to go first index, second index, third index, fourth index, fifth index. So I actually want to, as I'm going this way, I want it to go higher. So I actually want to shift this down by 4. Self.p1 as U32, and I'm going to shift it up because that's a full, and so I need it to be on the like other side. So shift it up by would be 8, but it's minus 4, so it's shifted up by 4. Is it P1? It's not P1, it's PF. Self.pf 2 as U32, and then we're going to shift that up by 8 plus 4, so we're going to shift that up by 12. And that won't fit in a U16, but that's fine. Try shifting the cast value. Yeah, it doesn't like any of this. What is it saying? Oh, I messed something up real good. So basically, for the first part of this, we say let index. So that's our index into the thing. And then we'll take 1. So then we'll take 1 and we'll shift it by the index and take and if that, yeah. So if this is equal to 0, no, if this is not equal to 0, so if that playfield has something in it, uh-oh. Then else we're going to do something different. All right, so our buffer at, so we know our index is our actual column into the buffer, but we need to know the line. So do let line equals, do that. I divided by color clocks per line. Then if the column is greater than, and the line is, we have that down here. Is drawing line. Line is less than 40. It's greater than or equal to 40 or less than 132. So if the column is greater than 68 and it is a drawing line, then we can set the buffer to, so we have a line number, so we have a line. We need that to be minus 40. Times our width. So super. And that gets us to the right line plus I index. And actually we need to copy like the next 4 over. Okay, this logic is not going to get resolved in the next 10 minutes. So I'm going to call it there. And unfortunately, we're stopping short of actually drawing something onto the buffer, which is a bummer, but I don't think I can stretch this any longer. So next time we'll be drawing stuff onto the buffer, I believe. Hold on one second. Let me look at something before I go. Just gonna remember how somebody else chunks exact mute. Yeah, so we actually need to offset this whole thing by 4. I know, Dead Beef. I'm sorry. I over promised. I'm trying to see what I can do here. I think I can just. This is gross, but I think I can just multiply this whole thing by 4. We'll call this start. So if it's foreground, we're gonna paint it white. This is gonna be used between all of it. So if they feel set, otherwise 0, 0. Boy, if this works. I would not bet my money on a first time here, but attempt to subtract with overflow 223. Line might not be 40. Why wouldn't it be? It should be greater than 40. Greater than or equal to 40. Shouldn't get past here. Oh, and second time? Yeah, okay, thanks, Clippy. Shift left overflow, no. Okay, This is probably where it goes over. So we actually need to be like mirrored. Let's be silly because I really want to see something today. I'm excited about it. So, and then we're just going to do this in reverse. um, so we'll actually just take this whole line. And then we'll do this part. And then this part. We'll have to figure out the shifts there. And then this part. Unexpected token somewhere. Did I not? So I then shifted over by 4 or 8 more, so 20. And then I shifted over by, this is for a reflected playfield, which we have. Oh, we don't have a reflected playfield, so it's just the same thing over again. Okay, so I was kind of right the first time. So, but then shift it left, it would be 20, but it's -4, so I shift it 16. And then I shift that 8 more, so that's 24. So then I shift that 8 more, which is 32. That should work for us. This is not reflected and bad as well. Yes, I know that. Shift low left overflow. The same place. So this is a times 4 that I missed. So the index or divided by 4 that I missed. So that's very Oh, I know it's wrong. So it's pretty funny though. So I actually need to like fill these up. It is something. It just is a completely insane thing. I have to fill all 4, but I was like, why is that so wrong? And it's because I realized that I also have it's an alpha channel, so I don't want to make that alpha 0. Come on, Rust Analyzer. That's also just very wrong. So I'll have to debug that later, but I'm not even sure what could be happening there. Just, just because I want to know what this is. That might not be very helpful. Oh man, I'm shifting things all kinds of wrong ways. So this gets shifted over 16. I don't think that's it. Because I'm still adding. Yeah, no, but it's 0 on the bottom part of it. So, okay. So something happened and it cleared, but you could see it for a second. Um, I have something very wrong. I think what I have wrong is that I actually have double lines on, and then something's going wrong where it's like the play fields are resetting. Um, I wonder if I could slow things down so you could see what's actually being drawn there. I have graphics, but they are real busted. This is 837. 37. So if I slow it down 10x, so each clock cycle is like takes a long, long time to run. It's still like super duper fast. How about 100x? It's all wrong, but those are graphics from the Atari 2600. Okay. That does have to be my day, but wow. That is so wrong. Let's look at that one more time. Let's probably, but it'll take me a long time to get there. I could probably do each instruction. Um Especially once we start drawing. So this is like 1,000 times slowed down. It's supposed to say tic-tac-toe if you can't tell. Yeah, I gotta call it. That's funny. Um, it's beautiful. I'm gonna share that far and wide. Okay, all right. We can raid with all three of us. Wonder if anybody else is doing emulator development. Let me mute that. Let's see. See if anyone's doing Rust. Yeah, working through hands-on Rust. Oh, hey, hold on. Hedgens here. So we'll go to Hedgen. All right. Catch me next time. I'm going to try and figure out what's going on with that in the meantime, but that was pretty funny, at least. So there's that.